All right, here is a problem. It's saying siderite is a mineral consisting largely of iron to carbonate. Write an overall balanced equation for its reaction with nitric acid and name the products. Okay, so this will just give us a little bit of practice with naming and formula writing, as well as predicting of the products. Okay, so iron to carbonate, and I'm writing a reaction with with nitric acid. Iron to carbonate and nitric acid. Now, what does this iron 2 mean? That is the charge. Okay, so let me write this out. And my charge for the iron is 2, and I'm putting this with carbonate, which has a -2 charge, CO3 with a -2. Again, that's one of those things that you need to memorize. So +2, -2, iron 2 carbonate is just FeCO3. Okay, and I'm putting that with nitric acid. Okay, nitric acid, you'll recall from the naming of acids, those rules. When we have that ic acid, it comes from anion endings that are ATE. Okay, if it's IDE, it is hydroic acid, and if it's ITE, then it would be nitrous acid. Okay, but ATE, like nitrate, in other words, is the anion that forms nitric acid. Okay, so nitrate has a -1 charge, which means I need 1 hydrogen, which has a +1 charge, to balance it out. So nitric acid is HNO3. Okay, so I'm reacting these two together. What are my products going to be? Okay, I have similar sort of thing to what I've done before. 2 ionic compounds, or at least in solution. Since this is acid, it is in water. And so when I and this is a mineral, by the way, according to the question. So I would put a solid there. It's a solid mineral. I'm reacting that with an acid, which is in water. Acids are always in water. At least almost always. And so what are my products? Iron will combine with will switch partners and become iron nitrate. Iron 2 nitrate, we're going to keep that same charge. Nitrate is a -1, so I need 2 nitrates to balance out the +2 charge of the iron. Okay, and then on the other hand, I get hydrogen with my carbonate. Okay, and so that forms carbonate is a -2, so I need 2 hydrogens, each being a +1, to balance that out. All right, so there's my equation, but I need to realize that this H2CO3, this is carbonic acid, the carbonate, so the 8 becomes ic acid, carbonic acid, carbonic acid. It breaks down into water and carbon dioxide. Okay, you can see the elements there. If you take carbon dioxide, CO2, out of that, you have H2 and 1 more O for water and carbon dioxide. Right? So this is a gas, this is a liquid, and then my iron nitrate, nitrates are soluble, so this will just be aqueous. I'm writing it like this because we're not interested in the net ionic equation. If I were going to write the net ionic equation, I would break this apart. However, these ones I would leave alone. They're not ionic compounds, so I just leave them the way they are. Okay? And then I have those same reactants. All right? So that is my completed equation. Iron carbonate solid, iron 2 carbonate, plus nitric acid produces, and what's the name of this? Well, iron is still iron 2, so iron 2 nitrate. Okay, and water, that's an easy one. We don't have a systematic name for H2O. Since it's so common, we just use water. But this one, this is a molecule. Two nonmetals make a molecule, or it's covalent bonding, not ionic bonding. So the rules for covalently bonded compounds, we use the Greek prefixes. For one, it's mono. For two, it's di. However, for the first element, we never include the mono. So this is just carbon dioxide, as though you didn't know that. Okay. And so those are the names for those compounds, and those ones were given to us, the iron 2 carbonate and the nitric acid. All right.